Hello, and welcome to this video introducing quadratic functions. Quadratic functions are another family of functions very familiar to you. After linear functions, these are perhaps the next simplest functions to consider, and they exhibit interesting patterns and very consistent behavior. In this section, you'll see how the average rate of change of a quadratic function on consecutive intervals of the same length reveals powerful information about how the function changes and what this says about the overall shape of its graph. In addition, you'll study one of the most important models that uses quadratic functions, the height of an object falling under the force of gravity, where the object's height is a function of time. We'll also remind ourselves of some important properties of quadratic functions that we've studied in past courses: the quadratic formula, factoring a quadratic expression into a product of linear terms, the vertex of a quadratic function, and the symmetry a parabola exhibits. Throughout, it's important to think of the two standard forms of a quadratic function, either q of x equals ax squared plus bx plus c, or q of x equals a times the quantity x minus h squared plus k. We want to think of these two standard forms as infinite families of functions that depend on parameters, either a, b, and c, or a, h, and k. As you study and think about the ideas in this section, work to understand how changing one or more of these parameters affects the resulting behavior of the function.